I'm here with Jim Adler, the managing director of Toyota AI Ventures. So Jim and I have known each other in several previous lives around data and AI.
Yeah,
so it's great to be with you.
Yeah, great to reconnect.
Thanks. So I just want to jump right in because I asked this to everyone in the autonomous vehicles space, which is how many years until self-driving cars are on the roads? Well, they're already on the roads, but on our public roadways.
I think sooner than we all think, but not everywhere we would want. And what I mean by that is it very well may be the case that your ride-hailing car may show up without a driver for a specific trip when the roads are good and the weather's good. But when any of those things are not true, a driver will show. And so when people say, when will we have self-driving cars, they tend to think, I think the general public, is everywhere, any time. And that is really a difficult problem, which we can talk about. That's going to take some time.
Right, really. It's going to be a mix of humans interacting with the vehicles.
That's right. Cars are social.
But if cars are social, that's where the biggest problems lie, as we've seen. It's actually when autonomous vehicles are driving together, they're okay. But when the humans are with them, then they misread each other's signals.
That's right. That's right. And when autonomous vehicles will have to interact with human-driven vehicles, with pedestrians, and with bicyclists, you may be able to perceive everything in the scene, but then you have to predict where these are all going to go. And so you see some pedestrians at a corner, and if it's two teenage kids with a skateboard, they'll probably go against the light. But a mom with a stroller, probably not. So you have to parse even deeper to understand the behaviors of all these objects you've identified. And even if you have identified them correctly, then you have to predict what they're going to do, and it could be different in different parts of the world.
So you have to factor in how that human beings will break the rules. Cars may be trained to follow all the rules of the road, but human beings know the rules and then break them. And so you have to factor in, the car has to factor in whether the human's going to break the rules.
Yeah, exactly. The best example of that is, should an autonomous vehicle drive the speed limit? Because, come on, we all know how many of us drive the speed limit. So should autonomous vehicles drive the speed limit? If they do, they may not be as safe because they're clogging up the flow of traffic. Maybe they should drive like the median driver. Not too fast, not too slow, just within the flow, even if that means that they are going faster than the speed limit. Is that okay? That's a policy question.
It's an interesting question. So Toyota AI Ventures is just a few months old. You founded it this summer with $100 million. But your competitors, BMW and GM, have had these venture arms for several years. So is Toyota playing catch up? And if so, how are you going to overcome that?
Well, I think that it's important to understand why you would do something like this and establish a venture arm. And I think what's so important is to get some signal from the marketplace. The amount of disruption is accelerating. And so what Toyota may have thought would happen in a decade may happen on a much more accelerated time frame. And as that accelerates, you need more signal. And so we looked at the marketplace, we saw the rate of disruption, and we said, things are moving very quickly. And we need to get a signal from those that are disrupting the marketplace. And startups, from my background, having been on the other side, the entrepreneurial side, for much of my career, startups are running experiments in a market laboratory. And we want to tap into those experiments. And we want to be shareholders so that if they're successful, we win as shareholders. And if they're not successful, we learn lessons.
So how will you catch up when others have the same strategy, but they're several years ahead?
Well, I think that you can always learn the lessons that others have learned if you're attuned. But as things accelerate, you want to have firsthand knowledge. Maybe if things are going slower, you can suffer secondhand knowledge. But as things accelerate, you need firsthand knowledge. So as things have accelerated, we looked and said, maybe it's time for firsthand knowledge. And that precipitated this decision.
So I really enjoyed actually hearing about some of the companies that you invested in. Tell me about some of the most interesting ones.
Yeah. Because we are a subsidiary of Toyota Research Institute, which is here in the Valley and focused on self-driving cars and robots and all the technologies that go into that, we get a first look at the pain points that is inhibiting being able to have self-driving cars anytime, anywhere. And so one of the issues that we struggle with, I think the industry struggles with, is power. These autonomous vehicles, they eat a lot of power. And so we are very interested in low power computing. So one of the companies one of our first investments was Slamcore. They're a company out of London. And they are about localization and mapping and computer vision. But what we are really interested in is their work with event cameras. And if you look at most vision systems in an automobile, a self-driving car, they're taking between 15 and 30 frames a second of video. Even if nothing is really happening in the scene, they're still cranking through all those frames of imagery.
15 to 30 frames.
Yeah, of a second. If they're looking at a tree, okay, you don't need 30 frames a second to watch a tree. And so what you'd like to do is dial down the frame rate if the entropy, the rate of change in the scene, is low, and you'd like to get maybe 100 frames a second if things are happening very, very fast. And so that is an efficient use of power, because most of the power is used crunching through all that data, all those frames of imagery, and it'd be nice to do it in a smarter way. We were very excited about that.
Okay, so power is one big issue.
Right.
You mentioned mapping. We all know there's a
Right.
flurry around
Right.
how do self-driving cars, which create their mental maps of the world and then drive along those mental maps, how do you improve those maps, and which companies have access to those maps? What are you looking at mapping? What are the other big pain points?
So mapping, we look at it as just another sensor.
Okay.
So there used to be these more religious wars around LiDAR versus cameras, and the reality is that it's going to be a multimodal set of sensors. I mean, LiDAR doesn't see through snow. Steam coming through a manhole cover looks like a post to LiDAR. So cameras don't see really, really far into the distance. So they all have their limitations. Imagery from radar doesn't have the resolution often, but can see through rain, through snow, and through steam. One of the companies that we really were excited about is a new investment in real-time robotics. If you look at the stack of autonomous driving, there's the perception of what the sensors see and seeing all the objects and parsing them in the scene. Who's the car, who's the pedestrian, who's the bicyclist, and then predicting where they'll go, as we talked about, and then planning, once you know that, what will the car do? What will the robot do? Because a self-driving car is really a really big wheeled robot. And the planning is really important, and we invested in real-time robotics that is proving the speed of planning, the number of plans that it can evaluate, by 10,000 times. So as an investor, you always think, all right, I want 10x improvement in price performance. And so when these guys came in, it was 10,000. We're like, how do you not do this deal? It's 1,000 times better than our criteria. So we, of course, had to do that deal, and we think that's going to be really important.
It's fascinating. So let's talk more about safety, because I know you have investments there. We saw with Tesla last year with the accident that the lack of safeguards and self-driving technology can lead to serious casualties. So what specific changes are you making to your current and future autonomous vehicles to limit accidents? And also, what level of safety are policymakers and is society ready for around self-driving
So there's
cars?
two questions in there, I think. I think the first question...
It's probably like 10, knowing me.
Right, I'm sure, but let's stick with two. The first one is, how do we make drivers safer? And I think the thing that's great about making drivers safer, not driving, but drivers, is that we can do that now without any changes in regulations. So it's really an important give back to the society, because 35,000 people die in car crashes every year in the United States. And if we can use autonomous technology to help drivers be safer, we can save lives right now. And we're really, at Toyota, we're really motivated by that. And so if you look at our autonomous driving stack, everyone said your first question, when will you have self-driving cars on the road? But before that, you can flip this and have the autonomy guard the human driver.
The car watches the driver.
The car watches the driver. And most accidents happen from speeding, drunk driving, distracted driving, drowsy driving. The autonomy can detect that and make a driver a much safer driver and save lives now.
So I remember one of my last stories when I was at the Wall Street Journal covering big data was about this. It was literally called When the Car Watches the Driver. Mm-hmm. And it was about sensors that were being put into vehicles that could look and follow if the driver was getting distracted, if their eye was looking too far to the left or too far to the right, and that would mean it was a sign of distracted driving. And then the question was, okay, the car can react, but what could the car do? Is it going to ping you or pinch you or tighten your seatbelt or make a ding? And they were actually experimenting with how to notify people because it's really annoying to get those kind of notifications all the time.
Exactly.
Like you don't want to be driving and doing that.
That's right. So how do you do that?
How do you do it?
So we have another investment in a company, Nado, that's helping that problem with fleet drivers now. The second part of your question, though, is what can we do from a policy perspective to make a decision of when this technology is safe enough to use, say in level 4 we call it, which is more geofenced, autonomous or driverless operation. And that's a really hard question. And it's not one that only technologists can answer. I have this framing that I love, which is the three critical roles are the geeks, the suits, and the wonks. And the geeks are the technologists that come up with the tech. The suits, they make the money that actually lets us improve things for a long time in a sustainable way because they pay the bills. And the wonks are the ones that sort of embed our values in our tech. And they could be, yes, attorneys and regulators and legislators, but they're also journalists and historians and philosophers and poets. And they are the guardians of our culture. And the question of how safe is safe enough is really a question for all three groups. And Gil Pratt, the CEO of Toyota Research Institute, gave this great talk at CES last January asking this question, how safe is safe enough? Is 17.5 thousand deaths a year okay? 17,500 deaths okay? That's half.
Half of
35,000
people are killed in cars currently.
Is that okay? If for a self-driving car to only kill half as many people? No. What about a tenth? 3,500. Is 3,500 deaths at the hands of a robot? Is that okay?
But there's big disagreement on
That's
that.
right.
People have much lower tolerance for robots than they
That's
do
right.
for what
That's
humans
right.
do.
It turns out we were much forgiving of our fellow human beings, and we have like near zero tolerance for artificial intelligent devices and any malfunctions when they harm human beings. So we have like no tolerance. So then who's going to make this call? And I think as a society, we have to get comfortable with it.
So what's your answer?
My answer is we need to think about this carefully and come together and I guess what I think is going to happen is we're going to look at the situations that are unavoidable. One of them, there's some tragic situations like the dart out. The only time my dad ever spanked me, I remember this. I was like 7, and I ran out between two parked cars, and he freaked. And he grabbed me, and and that's the only time. It's my only memory. And it's so wild that so many years later, that's one of the most dangerous situations there is in driving. And so,
Your dad knew.
yeah, he knew.
And all these
Yeah,
years later, now
we
you're
need to embed his brilliance into these cars.
Right, now you're teaching a robot to embed his
That's
values.
right, that's right. So the robot's going to whack us. But I think that there's certain set of corner cases that we have to get comfortable with that no technology, no human being can avoid, and can we be comfortable with those?
So I want to take a moment to ask you about Uber and Waymo and this massive lawsuit that's happening right now. So it looks like, Uber's self-driving program is going to suffering massive setbacks. What's the future for that? And if they do lose the suit, what's the future just overall for them and for ride-sharing companies in this mega battle for the future of transportation?
Well, I don't want to comment on things I know nothing about, at least publicly. But I will say that a few years ago, nobody really knew how this technology would evolve. When Uber started their project and when others Waymo embarked on their self-driving project, no one knew how quickly things would advance, how much investment would pour into this business.
So they thought they had to do it all themselves.
They thought, oh, if we don't have it, we'll be killed in the marketplace. And so I think that's changed a lot. There is nearly 300 companies working on self-driving technology and the software stack around it. And so, and there's tremendous money chasing this. Deutsche Bank did this study that said there's 65 cents a mile that's up for grabs in self-driving technology. If you do the math, there's 2.5 trillion miles driven in the United States every year. So 2.5 trillion times 65 cents is more than $1 trillion opportunity. There's a lot of money to be made here. So the investment is pouring in. And so my sense is whoever loses that lawsuit is going to have another supplier to buy from.
Which wouldn't have been the case when they started.
Likely not, or they didn't think so.
That's very interesting. And what about GM? I mean, I know they're a competitor, but they're partnering with Lyft. They bought Cruise, so they're building their own technology. They're creating their own ride-sharing network. Potentially, could they leapfrog ahead of Silicon Valley companies even?
The challenge with this business is again back to the long tail. There's a lot of corner cases that are very difficult. We talked about the dart out. We talked about the difficulty with sensors.
Is that an industry term, the dart out?
I don't know if it's a term of art.
I like that.
Well, maybe we'll coin it here today. I think it is a term of art. So what was the question?
Oh. Yeah. Could GM leapfrog ahead of the others?
Because of how they're, right? You want me to comment on competitors again, right? So I think the winner is going to be who has the data. I think this is a data play, and so because how do you learn these corner cases? You learn them through data. Mark Andreessen famously said, "Software is eating the world." Software is built on algorithms, right? Hardware was built on physics. Now, the new big fish in the ocean now is artificial intelligence, which is built with data. And so, who has the data? Toyota has a rather large market share in the auto industry. I'm betting that data haul will be really important in the long run to understand all of these cases, all of these unique situations all across the world to make sure that we can train our artificially intelligent self-driving robots to understand all the cases and therefore provide a very safe vehicle.
Got it.
Experience.
So before we close out the session, they wanted me to ask you these rapid-fire Q&A.
Oh, right.
Right. So you have to answer overrated. I'm going to shoot out a word, and you answer overrated or underrated.
Okay.
I'll just rattle off some companies and some trends. Okay. Bitcoin.
Underrated.
Blockchain.
Underrated.
Machine learning.
Overrated.
Facebook.
Overrated.
Google.
Underrated.
Autonomous cars.
Underrated.
Uber.
Underrated.
Amazon.
Underrated.
Data security.
Well, I'm long data security, so underrated.
Tesla.
Tesla's overrated.
Thanks so much, Jim. It was
Yeah,
great to
thank
talk
you.
to you again.
Thank you.